All right, guys, so this is our second foldable for 8.2 and 8.3, and this will be our final one as well. This is just more practice problems, so hopefully there's no new introductions here, just more problems and examples to work through. So if you folded it, this should go in order nicely, and I highly encourage you to fold it up before we start this, just because it'll make it a little easier to navigate. But if for whatever reason you don't want to, you might have to pause and kind of go and find certain sections, because this is organized in a sense that if it's already folded, this is the order it goes. All right, so the foldable, the top part should look like proportions and triangles. And when you lift this up, you see this right here. Okay, so it says if a line is parallel to one side of a triangle and intersects the other two sides. So in other words, if this and this have to be parallel, okay, then it divides those sides proportionally. Okay, and once again, I'm going to get my highlighter out, and I'm going to highlight the sides that are divided proportionally. So this one, this one, this one, and this one. Okay, so I can say if that happens, if I let this be A, this be B, this be C, this be D, then I can just say A over B equals C over D. All right, so let's do some examples. So I'm going to do this one first. Now, if this whole thing is X, and this piece right here is 15, this piece here has to be X minus 15. Okay, and now I'm going to put these proportionally. So I'm going to highlight them all different colors. And then I'm going to set up a proportion. So I can say 20 is to 8 as 15 is to X minus 15. Okay, from here I cross multiply. So 8 times 15 equals 20 times X minus 15. Don't forget to put this in parentheses like I just did, okay? That will give you a wrong answer if you don't. And the reason we do that is so I can distribute that through. So 8 times 15 gives me 120 equals 20X minus 20 times 15 is 300. Then it's algebra, so add 300 to both sides. So 420 equals 20x, divide by 20, divide by 20, I get x equals 21. Okay, so I encourage you to go through and do these two on your own, and then we will go over them. All right, so this is what you should have gotten for the other two. So if this whole thing is 27, this is 15, of course this has to be the rest to where 12 plus 15 is 27. So you set it up, 15 over 12 equals 20 over x, and you should get x is 40. Okay, down here, don't freak out if you get a decimal. It's a big, long, scary looking number, but it's okay. So if this whole thing is 20 and this is 6, this has to be the rest of it. So 20 minus 6 is 14. So you'd set it up as 14 is to 6, as 4 is to x minus 5. Now don't forget to put this x minus 5 in parentheses. Okay, and because it's in parentheses, you would then have to distribute the 14 through, and you would end up with a big long decimal. Like I said, it's roughly 6.7. One more thing is this says it's the side splitter theorem. We're going to cross that out because our book doesn't call it that. Our book calls this the triangle proportionality theorem. Okay. All right, guys, let's go to the next page. So if you flip the next page up, you'll see this right here on top. Okay. And this says if 3 parallel lines, so please note these all have to be parallel. they intersect two transversals, then the segments intercepted on the transversals are proportional. Okay, so once again, if I highlight each of these in different colors, and then I label them, if this is A, this is B, this is C, and this is D, then it would cut these to where A over B is going to be equal to C over D. All right, let's look at this one first as an example. Okay, so notice all of these are parallel. Okay, so I'm going to go ahead and I'm going to highlight these. Okay, oops, that should have been a different color. Let's do that right there. Okay, now I'm going to set up proportions. So I can say 27 over 18 is going to be equal to x plus 10 over x. Now remember, I have to throw this here in parentheses. Okay, so when I cross multiply, I get 27 times x equals 18 times parentheses x plus 10. All right, so this is just 27x equals 18x. I'm distributing this through, plus 180. Subtract 18x on both sides. I'm left with 9x equals 180. And if I divide both sides by 9, I get x equals 20. That's my final answer. All right, go ahead and do this one here on your own. Now you have to read to make sure you know what each one is. So AB is 25 minus x. Okay. BC here is 25. FE is 4. And then DE is 16. Okay, so go ahead and set up a proportion and solve. All right, so you should have set up your proportion. 25 minus x over 25 is equal to 4 over 16. Now, guys, there's several ways you can set this up that'll be correct. But if you set it up correctly, you should have ended up getting 18.75. Remember, this here goes in parentheses, and then you have to distribute through. All right, one more thing on this page, guys. On the very bottom, it says the side splitter theorem corollary. That's not what our book calls that. Okay, so under it, I want you guys to write parallel lines and transversals, proportionality, theorem. Because that's what our book calls it. All right, let's go to this part here. So on the very bottom of this, it has the triangle angle bisector theorem, and that is okay because that is what our book calls it. Okay, so if I look at this, it says if a ray bisects an angle of a triangle, so notice here, it does bisect it because it cuts it into two congruent parts. Then it divides the opposite sides into two segments that are proportional to the other two sides of the triangle. Okay, so once again, I'm going to highlight sides. Highlight this yellow, this green, purple, and blue. Okay, and then I'm going to set up a proportion. So I'm going to say 27 is to x as, now guys, if this whole thing is 40 and this is x, this has to be the rest, so this is 40 minus x. Okay, so 27 over x is equal to 45 over 40 minus x. Now, make sure we throw this in parentheses. It makes a difference. Here I'm going to cross multiply. So I get 45x equals 27 times 40 minus x. So 45x equals 27 times 40 minus 27x. If I add 27x to both sides, I get 72x equals 1080 divided by 72, and I'm left with x equals 15. All right, go ahead and do these two on your own. You are going to use that same theorem because this angle's bisected and this angle's bisected. If you look over here, if this whole thing is 15 and this is x, this part has to be 15 minus x. And you should be able to do the rest from there. So go ahead and do both of these and then we'll go over them. All right, so on this first one here, you're going to set a portion. So 24 over x plus 2 equals 18 over 12. And remember, you have to put what's highlighted in yellow here in parentheses. Okay, and you should have come up with x equals 14. Now on this one, if you didn't know how to solve this, that's okay. You'll be reminded in Algebra 2 because we do get a quadratic equation, but you should have been able to come up with this. So 10 over x equals x plus 15 over 15 minus x, and you really should have gotten to this point too. But if you didn't get to x equals 5, that's okay. You'll review how to do that in Algebra 2. All right, so let's look at this. Let's find x first. Okay, so when we find x, we're going to use the triangle proportionality theorem. Which basically says that if these two are parallel, then it cuts it proportionally. So I'm going to highlight these. And guys, if the whole thing's 37.5, this is x, this has to be 37.5 minus x. Okay, so I can set up a proportion. I can say 9 over 13.5 is going to equal 37.5 minus x over x. Okay, and don't forget to put this in parentheses. So I want you to go ahead and solve this from here. I've done the hard part, now you solve it. All right, so as you worked it out, hopefully you put this in parentheses, you should have got your final answer as x equals 22.5. All right, now let's solve for y. And we're just going to solve this by using properties of similar triangles. And more notably, we're going to use the angle-angle theorem as well to show that they're similar. Okay, so if these two are parallel, then this here and this here angle are congruent. And this here and this here angle are congruent. And therefore, by angle-angle similarity theorem, this top triangle here is congruent to this whole triangle. Okay, so for this whole triangle, this is 9 plus 13.5, so this is 22.5. Okay, so I can say that this here, so 9 is to this whole thing, because we're looking at the whole triangle, 22.5 equals 7.5 over y. Okay, now go ahead and solve this. All right, when you worked it all out, you should have gotten y equals 18.75.